morning, friends. Today we are starting a new sorting algorithm, that is insertion sort. Insertion sort is one of the easiest sorting algorithm that we ever used. It is very easy to implement. This sorting technique we are using as from our childhood even. Like I hope you people have remembered that we were playing in our childhood playing cards. We have played that. And whenever you are having playing cards in your hand, we always try to arrange them in a way that we can play in a better way. So what happens if any of the card we need to arrange it like that? That means that card should be inserted somewhere in between of the previous cards. So what we need to do, we need to shift all card into the right side. Then we made the appropriate place wherever the resultant the next card can be placed, can be inserted in our hand. The same approach we apply into the insertion sort. Like if we continue the same example, let's suppose I have the four cards in my hand and I need to place the fifth card at this point. So what I need to do, I need to shift this fourth card into right side. Then I need to shift this third card into the right side. These two cards will remain same at its own position. Then this fifth card will be placed here. This is the way that how we achieve the insertion sort. It is the basic logic of the insertion sort. So I have written the C function of the insertion sort into the right hand side of my board, and here I am taking an example. So first I am taking an example, then I will show you that how this algorithm will work. Always remember when you are applying the insertion sort, it always starts from the second element. It always starts the second because the first element is already at its right place as the algo starts. Because if we have only single element, there is no need to apply any kind of sorting technique. That data is already sorted. Now, what will happen when we apply it with the second element? What you need to do, you need to compare this value, which is at the second position of our array, with the all values which are left to that second element. It means if we are at the second element, so we need to compare it with the all previous value into the left hand side. So what will happen? We will compare this 2 with the 5. We will compare 2 with this 5. So as we know, if we are storing our data into the ascending order, so 2 should become before 5. So what will happen? I need to shift this 5 at the place wherever the 2 is. When the 5 will shift at the place wherever the 2 is, so we have an empty space at the position wherever the 5 was. So what it means, this 5 is shifting from this position to this position, and this position become empty. So what we will do, we will store 2 at this position. So that means we have the resultant array like this. In one way, it looks like a swap. That means we swap the values 2 and 5, but exactly we had not swapped here. In the later on example, we will see that it is not a swapping, it is basically a shifting. Now, because we have done with the second element, now we will do with the third element. We will do with the third element. Now start comparing 4 with 5. So as we know, they are not in order. So we need to shift 5 to the right side. Then we need to compare 4 with 2. As we are comparing 4 with 2, so we know that 2, there is no need to make a shift operation with the value 2. Because 2 should become before then 4. So it means 2 and 4 are already in order. It means 2 will not move or shift. So if 5 will shift at this place and 2 will remain at its original place, then we will have one empty block. So what we will do, we will place 4 at this place. It means like this. Again it is looking like an, that means as we have swapped the values. But I told we hadn't swapped it. We are shifting exactly. So okay, we have done with the third element. Now we will do with the fourth element. When we are doing it with the fourth element and we are comparing 6 with the 5 and we are finding they are in order, so there is no need to apply or there is no need of any comparison with all rest of the element. Because what happened with this part of the array, if you look at here, so this is already sorted. So if any value which is higher than to the last value of this section of the array, so there is no need to compare it with any other part, with any other element. So it means in this example, when we have considered the fourth element, so it is already greater than to the third element, so there is no need of any kind of shifting. In the next step, we are coming to the fifth element, and the value of the fifth element is 1. Now look at here very carefully. We are comparing 1 with the 6, so they are not in order. So what we need to do, we need to shift 6. We need to compare 1 with the 5, again they are not in order, so we need to shift this 5 also. We need to compare now 1 with the 4, again they are not in order, so we need to shift this 4 also. Now we are comparing 1 with the 2, again they are not in order, so we need to shift this 2 also. Because as we have shifted 6 here, 5 here, 4 here and 2 here, so we have one empty block in the starting of the array. If it happens, so this 1 will be shifted to the first position of our array. So 1 is coming here. And now we are coming to the last element, that is our 3. So start comparing 3 with the 6, 6 will shift. Start comparing 3 with the 5, 5 will shift. Start comparing 3 with the 4, 4 will shift. Start comparing 3 with the 2. It will not shift. That means the shifting process will continue if we are having greater element to this key element. The element which we are pointing will be considered as key element on each of the pass. That means in this pass, this 2 was considered as a key element. In this pass, 4 was considered as key element. In third pass, 6 was considered as key element. In fourth pass, 1 was considered as one key element. And in the last pass, 3 has been considered as a key element. So the shifting process will continue if the key value is smaller than the values which are to the left of its array. And if it is greater than to any of the value, then this shifting will stop. So what will happen? 6 will come to at the end, 5 will here, 4 will be here, 2 has not been shifted, and so we have one empty block where we can store 3 basically. So this is the way that how insertion sort took place. Now come at this function. We have applied in the same way. Here we are having array, we are having the size of the array. In the C language, the indexing starts from 0 to n minus 1. So that's why the index of the second element is 1. We have took it to the last element, and every time the index will increase. We have considered the first element according to this j as a key element. This is what we have did here. Then we need to compare it with all the element of the left hand side. Then we have taken I here, and the value of the I we have initialized with the j minus 1. So we are taking few of the variable, that is I, that is j, that is key, that which we are required to perform this function. Here we are having the loop, while loop, that is inner loop of this array, and we will run this loop until this I is greater than equal to 0. That means the shifting process will done till the last element in the left hand side. That means to the first element of this array. And this here we are having the end condition. That means both condition must be satisfied before entering into this loop. That means the value of the AI should be greater than to the key. This you can imagine here. The shifting process will continue till the value of the AI are greater than to the key element. So basically in this section we are shifting. And how we are shifting? Every time this element is coming to here, this element is coming to here. That means AI is going to AI plus 1. So what we are doing? We are shifting AI element to the AI plus 1. And we are going backward direction. So that's why the I should be reduced by I minus 1. Because it is a backward loop. That's why we are doing this. And whenever we have a space where we need to put our element, so out of this loop, out of this inner loop, when we are coming out of this one, so the hole must be created, and at that hole we will store our key value to the I plus 1. This what we did here, because all the element has been shifted, so the black hole will create it here. If all the element will shift it, then black hole will create it here. If this element will shift it, the blank hole will create it here. Same thing if because all element has been shifted, so the I plus 1, the blank hole will be created. So the key value will be stored at that blank hole. So this all was all about insertion sort. If we talk about the complexity of insertion sort, in best case it is order of n, in average case, and in worst case it is order of n square. Thank you friends.